Hi, today we're solving problem 32. In this problem, we're told that an n-digit number is pan-digital if it makes use of all the digits 1 to n exactly once. For example, the 5-digit number 1, 5, 2, 3, 4 is 1 through 5 pan-digital. The product 7254 is unusual, as the identity 39 times 186 is equal to 7254, containing multiplicand, multiplier, and product is 1 through 9 pan-digital. Find the sum of all products whose multiplicand, multiplier / product identity can be written as a 1 through 9 pan-digital. They have a little hint at the bottom saying that some products can be obtained in more than one way, so be sure to only include it once in your sum. So in this problem, we're going to have two steps. The first one is calculating all of these triplets of number A times number B is equal to a number C, such that all of these numbers together are 1 through 9 pan-digital. And then we will remove duplicates and sum them up. So I can go over and switch over to IntelliJ. Now, the first thing we want to be able to do is, given the order of these numbers, split them up into this multiplication. So I'm going to write a method def split. It's going to take the length of A, which is the first number of type int, the length of B of type int, and the sequence of numbers, which is a sequence of int. Now here we're just going to return a tuple. We're going to do sequence dot take the length of A because it's at the beginning. Then we're going to do sequence dot slice because B is in the middle, so we want to remove the stuff from A and remove the stuff from C. So from is A len, and until it is sequence dot length minus B len. So we're getting the B, which is in the middle. And the last thing we're going to need to do is get everything at the end. So we're going to do sequence dot drop A len plus B len. So now we can split up a sequence into these three values. Now we can define the list of all possible multiplications that may work. So I can do val cases is equal to, we're going to do 129 dot permutations. What the permutation function does is it gives us an iterator of all of the different reorderings of all of the numbers in this sequence. Now I can do a flat map on this. So I take the ordering, and one thing we can notice about this is by doing a little bit of math, we know that the only cases that might work are where the numbers are of length 2 and 3 or 1 and 4. That's the only case when you may end up with the 1 through 9 pan-digital. So given an ordering, we can create a sequence of split. A len is going to be 1, B len is 4, and sequence is O. Or it'll be split 2, 3, O. So now that we have all of these cases, we need to actually check these. Before we do the math, we first need to be able to convert a sequence of integers which represents each of these numbers into a number itself. So we can create a method seq to int, takes a sequence of type sequence of int, and implementing this is easy. It's just sequence dot reduce. Reduce is just like full left, except its initial value is the first element of your sequence. So we can actually go into the documentation for reduce. So in here now, we're going to have this function with b and a, and all we're going to want to do here is take this accumulated value b and use a to add to it. So now, we have our accumulated and our current, and we're going to do accumulated plus 10 times our current. And that will give us an integer. Actually, we need to swap this. We need to do 10 times our accumulated plus our current. Because what we're doing each time is, we're taking the number we have so far, shifting it to the left, and adding in the next number. Now that we have this method to turn a sequence into an int, I can just do cases dot, and now I can convert this, I can do a filter first. So given a triplet, I need to check that sequence to int, the first number, times sequence to int, the second number, is equal to sequence to int, the third number. Now for all of these cases, I need to map this tuple, and I just want to the third number because we need to add up the third number in each of these cases. Now I can convert this to a list and sum them up and print on this whole thing. Now I can run. We got the wrong answer. Let's take a look at see what happened. So first let's start from the top. Here we have split, taking the length of the first number, the length of the second number. I think I see what happened here. When we're slicing, we're taking sequence.length minus blen. But that would make sense if blen was the last number, but it's not. What we want instead is alen plus blen. So remove everything up to alen and then take everything until alen plus blen. That's what we want. Now we can go ahead and run again. We need to do now a distinct, because what we're doing here is we are calculating all of these values but not doing a dot distinct. Now we can run. Whoops, 2 dots. ToList dot distinct, because we can do distinct on a iterator. And we get our answer, 45228. So that's it for problem number 32. I'll see you next time when we solve problem number 33.